Hi students, in this video I am going to discussing about the basics of serial communication. Serial communication uses single data line, making it much cheaper. Enables two components in different sites to communicate over the telephone. Bytes of data must be converted to serial bits using a parallel to serial shift register and transmitted over a single data line. That means a serial line. At the receiving end, there must be a serial in parallel. That means serial to parallel converter is needed, and here parallel to serial converter is needed before transmitting. After receiving, serial to parallel converter is needed for the data receiving. To transfer on telephone line, it must be converted to audio tones by modem for short distance. In this case, we are going to discussing about modes of serial communication. The modes of serial communication is classified into three categories: simplex, half duplex, full duplex. In the simplex communication, the transmitter is transmitted some data through this serial wire. This information is transmitted only one direction to the receiver. That means in simplex transmission, data can be transmitted in only one direction. That means from transmitter to receiver. There is no possibility for receiving the data from the other end, nothing but a receiver to transmitter. Only one direction is possible, one-way transmission. Here half duplex. Half duplex communication is data can be transmitted bidirectionally. That means if the transmitter sector is transmitting some data content, that time this receiver section will receive the data. That means this module, if it is acts as a transmitter, other module will act as a receiver. If this module is acts as a transmitter and other module will act as a receiver, that means bidirectional data transfer is possible, not simultaneous. In full duplex communication, here bidirectional data transfer is possible but simultaneously. That means simultaneously we can transfer at a time from module 1 to module 2 and module 2 to module 1. If it is a module 1 acts as a transmitter, that time module 2 acts as a receiver. So other end transmitter is acts as a module 2 acts as a transmitter, other end acts as a receiver. Here only one direction is possible. Examples are our printer to CPU communication or CPU to keyboard to CPU communication. And also another example is radio communication. In this case, we are going to see bidirectional transmission is possible but not simultaneously. Our example is police communication, walkie-talkie. In full duplex communication, we are using bidirectional data transfer is possible simultaneously. That means our telephone communication in our mobile communication. In simplex transmission, the computer can only send data. There is only one wire. The data can be transmitted and received, then it is a duplex transmission. Duplex transmission can be half or full duplex depending on whether or not the data transfer can be simultaneous. If communication is only one way at a time, it is half duplex. If both sides can communicate at the same time, it is full duplex. Full duplex requires two wires connect of data lines in addition to the signal ground. Basics of serial communication. Serial communication can be classified into two categories, that is asynchronous communication, synchronous communication. In synchronous communication, we are going to see synchronous method transfer a block of data characters at a time. The events are referred to a clock. Example SPI bus, I2C bus. Asynchronous communication, asynchronous methods transfer a single byte at a time. There is no clock. The bytes are separated by start and stop bit. In synchronous communication, transmitter and receiver, these two sections will use common clock. In asynchronous communication, receiver, this transmitter and receiver use separate clock. This is used for separate clocks, and also this is used separate clock for receiver. Into the synchronous transmission, in this case we are going to see only data packets without adding any start and stop bits and also parity bits. From the sender, we are going to transfer only this packet information. If it is size equal to 8, this 8 packet frames are arranged like this. This transmission is transmitted through this link, through this channel only we are transmitting to the receiver. But in the asynchronous transmission, we are going to see from sender to receiver, this is a one data format. Within this data format, our original information is there up to this white shade and this black shade which indicates the start bit, and this black shade after the data format which indicates the stop data. Let us see how this asynchronous transmission will frame the start and stop bits. Asynchronous transmission, this complete format can be represented like this. Initial bit acts as a start bit and ending bit acts as a stop bits. That means 1 or 1.5 or 2 bits are used for stop bits. So in between start and stop bits, we are using 8-bit data, that is called our word information. So coming to this one, start bit always indicated as a 0. After start bit, our actual original message signal starts like this up to 8-bit. After the original information, again we are using stop bits, either 1 bit or 1.5 bit or 2 bits we are using for framing the complete asynchronous data packets. Like the start bit and stop bits we are using, in between start and stop bit we are using original data 8-bit string like this.